first of all, we'll start off in the kind of a sequence. I'll lay it out. Is first Pierre Delforge will speak. I'm excited to have someone who's not an architect outside the architectural industry, a senior scientist with the Natural Resource Defense Council, NRDC, focusing on building decarbonization, climate, and clean energy programs for the NRDC, and that's great. Also we have Amy Ryder, principal consultant at Archimede Consultants in San Francisco. What's great about Amy is that she comes from a background that has a strong understanding and connection to government agencies, connection to cities and the government agencies that we need to speak to and speak their language to move this conversation forward. So that's great. And then coupling with that, we needed someone that could speak to the stakeholders and speak that language outside of the kind of architectural jargon. And so we have Matt Goff with the Sierra Club, who will then follow Amy's presentation and really speak to the stakeholders and translating this language into digestible language, and also who are the groups outside of the architects and engineers that we need to engage with to move this conversation forward. And then we have Scott Schell, who I had the opportunity to meet recently, principal at EHDD Architecture in San Francisco, AIA Committee Environment Advocacy Committee leader, and really a champion this for the past 18 months, brings a lot of wisdom and experience to the table and speaks at kind of the architectural perspective of how to maybe showing through doing, maybe some case studies and just really boots on the ground and providing examples of success stories that we can all learn from. So with that, I will now invite Pierre to unmute yourself, and I will take over just advancing the slides. Thank you.
Thank you, Jed, and thank you everyone for taking some time for this conversation. I'm really excited to be able to talk about this movement that has been sweeping California over the last maybe 18 months or so, and about how to decarbonize our buildings, led by community members, by architects, designers, activists, city staff, and council members. And that really has changed the conversation on building decarbonization from being not just top level, top down policy led, but also bottoms up. And so we've had a great movement. I think it's still at the beginning, and a lot of it actually has initiated in Southern California. So we want to see how we can expand from that early leadership and take this movement statewide. So I'm going to start with the big picture and lay out kind of the ground for this discussion, and have my colleagues Amy, Matt, and Scott talk about the process of this policy development, the organizing and advocacy behind it, and with Scott the technology and the design opportunities and options that are behind this decarbonization movement. So the reason we're all here, to the next slide, please. And unfortunately, I have to start with a little bit of a grim note. And the reason we're all here today and talking about this is because of the impacts of climate change. This is not just about the future and hypothetical. We're well placed in California, unfortunately, and tragically, to know that we're already experiencing the impacts today in very real and human terms. Tragically, a number of people have lost their lives. Many others have lost their livelihoods, their health. And unfortunately, we know that it's also going to get worse before it gets better. But I think the silver lining and the hope in here is that we can slow this down, and we have to, and we can eventually reverse it. And for this, we have to decarbonize the entire economy, including the building sector. So what does it mean for the building, which is the building sector, which is today's focus? So next slide, please. So as I mentioned, to decarbonize the economy, we have to get to net zero. And in a very broad brush, what this means is we have to get to the building sector down to zero carbon, so what we call a deep decarbonization. The way to do this is really the three major ways are: one, energy efficiency, which remains probably the biggest opportunity, so cut energy use. Second, clean up our source of energy, so the grid or even our rooftop solar panels. And third, use this abundant and clean and affordable supply of clean energy to power everything, to power our appliances, our vehicles, and but in this case, for today's discussion, our buildings, so all the energy use in our buildings. Next slide, please. So the building sector is responsible for approximately 2 billion tons of CO2 emissions in the US annually. That's out of 6 billion tons, so it's roughly about a third, and that's just from an operating perspective, not even including the embedded energy to build buildings. But just the operating operating energy use is about 2 billion tons. Half of that is from thermal energy use, which is basically heating and cooling, water heating, cooking, drying, fireplaces, everything that basically generates heat or cooling. And decarbonizing that, so transitioning from the use of fossil fuel in this sector to high efficiency electric can cut this energy use down by 1 billion tons. As long as we power it by clean, renewable electricity. So that's a huge number, and it's just the US. It's more when we expand it globally. And this is the opportunity that we have today of moving away from the use of fossil fuels in buildings to clean electricity powered by high efficiency electric heat pump technology. And I'm going to talk more about this in a minute. And so far, I've talked mostly about carbon, but it's not just about CO2. It's also including methane emissions, CH4. So the challenge with fossil fuels and with gas in particular is that a significant amount of it doesn't get burned. It escapes from either the well or the processing plant, the distribution pipelines, or even in our buildings, behind the meter from our appliances and pipe within the buildings. And it doesn't take a lot of this methane to leak to have a very significant impact on the climate. So next, please. The best science that we have today is around 2.3% of methane upstream of the meter. So that's from the well to the meter, and about 0.5% behind the meter. Actually, newer science is coming out showing there's even more than that. So it's about 2.8% and probably more than that is leaking out of their total gas use. And methane has a global warming potential much higher than CO2, about 86 times over 20 years. So it doesn't take a lot of methane leakage to have significant climate impacts. And actually 3.2% of leakage is approximately twice the climate impacts of burning gas. So just looking at methane, we're almost doubling the impacts of gas use from combustion. So this is a very significant impact. And obviously, one of the best ways to avoid that is to reduce and eventually eliminate the use of gas in the building as well as the economy. The good news, though, is we have a technology solution, and that's called modern heat pump technology, that is transformative in terms of being able to address this issue. Just like LEDs for lighting and electric vehicles for cars, this solution is about 5 times as efficient as the conventional technology for heating and hot water. So most of you may be familiar with this technology, but it's really fundamental to the value of building electrification to the grid, to greenhouse gases, and to consumers in terms of being able to reduce bills. This technology isn't new. It's been around for some time, mostly in the form of air conditioning and refrigeration. What's more recent is that in the last decade or two, it's been used more commonly for heating and water heating application. And it's become very efficient, very reliable, to the point that it's becoming the primary pathway to decarbonize our buildings today. Just heating and water heating is approximately 2/3 of energy use in the residential sector, And these are energy users that tend to be powered by fossil fuels today. So, we can put solar panels on our building, we can decarbonize our grid, but if we continue to burn fossil fuels to heat our buildings and hot water, we're missing a very significant opportunity. And heat pump technology is the opportunity to move these end users to clean energy. Next, please. So how much reduction can heat pump technology provide? This example is for a heat pump water heater compared to conventional water heaters. So you have, on the left bar, you have a gas storage. So basically the commonly used gas storage water heater that we find in most US homes. Then you have electric resistance water heater, which is the other commonly used water heater. Tankless condensing natural gas or tankless condensing natural gas water heaters, which are, have been built until recently as the more efficient options for water heating. And then next to them, you have the hybrid heat pump water heaters and the pure heat pump water heaters. And it's pretty obvious from this chart that the heat pump water heaters are less than half and sometimes around a third of the greenhouse gas emissions of conventional water heaters. And that's with today's grid. That's in today's grid in California. As California's grid gets decarbonized, we have a goal of 100% renewable energy by 2045. The emissions from heat pump water heating will get down to zero, which is not the case with gas. So this is to highlight the very significant, the transformative potential of using heat pump technology in buildings compared to conventional technologies. Next, please. And so far, I've talked a lot about the climate benefits of heat pumps and electrification with heat pump technology. But even if we weren't doing it for the climate, we'd have a very good case of doing it just for health reasons. Turns out that burning gas in our buildings for heating, hot water, and cooking is responsible for 7 times as much pollution, air pollution, as all the power plants in California. And that's because we don't have modern pollution controls on our gas cook stoves and furnaces, whereas power plants have been required by law to have pollution controls which reduce their emissions. But today the majority of the NO2, so the NOx, nitrogen oxide emissions, is coming from homes and buildings. I mean, there's transportation as well, which is a major source, but a large part of it is coming from our buildings, and we don't even realize that. And one recent UCLA study on air quality found that indoor combustion of gas, particularly from cooking, generates emissions level which often exceed the legal limits that's set for outdoors. Actually, that's on the next slide, I believe. Yeah, that's a chart from the UCLA study that shows on the left, you have the carbon monoxide, CO limits in red and blue, and you can see that a number of homes, actually about nearly 25% of these homes, regularly exceed the legal limits for carbon monoxide inside indoors. And then on the right-hand chart, you have nitrogen oxide, and you see the majority of homes actually exceed the legal limits for nitrogen oxide when burning gas for cooking. So that's a really strong case for moving to clean electricity. And the good news, and next slide, please, is that we don't have to compromise with inferior technology. We actually have superior technology to replace our gas stoves, which is called induction technology. It's cleaner, it's safer, because the surface doesn't get hot. There's not as much risk of burns. It's faster, it's more efficient than gas and even conventional electric stoves. And don't just take it from me, but next slide, please. If you look at the consumer reports, there are 5 of the top 9 ranges that they categorized were induction. The top 2 were induction. So this is the up and coming technology. It's better, faster, safer, and more importantly, most importantly, it's healthier. So no compromise here. But next one is, what about cost, right? This all sounds good. It's low pollution, it's lower greenhouse gases. How much does it cost? Can we afford it? A recent study, actually last year, a study done by a consulting firm, E3, which is Energy, Economics, and Environment, found that in the majority of cases, so on the 4 pie charts represent single family, multifamily, and then retrofit and or electric, in both single family retrofit and new construction, as well as all new construction. The majority of cases are already cost effective on the from an electrification perspective. The one sector that's still more challenging, where a smaller percentage is either not cost effective or slightly cost effective, is the retrofit of low-rise multifamily buildings. And we're pretty close to cost effectiveness. And as prices come down with market development, we expect that it's going to become cost effective very soon. But I think talking about new buildings here, the important thing is, both for low-rise multifamily and single family, in the majority of cases are cost effective today and are going to get more cost effective as time goes by and heat pump technology becomes more cost effective, just like solar panels, EVs, LEDs have come down in cost over time as sales volumes have come up. Next, please. The other important factor to consider is that when we talk about cost effectiveness, we have to consider not just today's prices, but the prices as they're going to be of the life of the building and the life of the appliances in the building. And there is a trend happening in the utility sector that is really important because it's going to fundamentally reshape the economics of energy use. The trend is that we're using less and less gas because of climate change, reducing heating loads, because of energy efficiency policies, and just because more and more customers are choosing to use electricity instead of gas. So there's a declining energy use on the gas side, and there's at the same time you have increasing cost of gas infrastructure because of pipeline safety regulations, because of trying to mitigate leakage of methane from pipes. So this dynamic of having increasing infrastructure costs that needs to be recovered on declining sales mean that you have a cost spiral that for every unit of gas has to recover more and more infrastructure cost. So next slide, please. So another study by E3 recently found that we anticipate the cost of retail gas to go up exponentially over the next 20 to 30 years. Slowly initially, it's not going to happen tomorrow, but over the life of the buildings that we are building today and the appliances that we are choosing to put in our buildings today, we are going to face significantly higher gas prices, and it's going to end up with much higher gas bills than if you choose to build all electric today. So this is something which is really important to consider. Let's not just look at today or yesterday's prices, but let's look at where we're headed and make sure that we plan for the economics of our buildings accordingly. And my last slide is really about one alternative that we've been hearing a lot, because the gas industry has been trying hard to make people believe that we don't actually have to change anything. If we just put a little bit of renewable gas in the pipeline, just 20%, that's going to be equivalent to electrifying everything. And unfortunately, it's not as simple, and this is actually a fairly gross misrepresentation of some studies that have basically been showing that if you were to use all available renewable gas in the United States and use it all in the building sector, not just in industry and transportation and power generation, but all in the building sector, you might be able to offset have the same impact as electrification. But obviously, it's not just about California, it's not just about the building sector. The precious little renewable gas that exists needs to be used in harder to electrify sectors like industry, transportation, and seasonal storage, not in buildings. So the real truth is that we just don't have enough of this precious renewable gas. It is super expensive. It's not affordable enough. And the other reality is that renewable gas still impacts the climate in the form of methane leaks. It's also methane. So it's also not entirely climate friendly. So I think the takeaway from this is, we do need some renewable gas to get to our zero carbon goals economy-wide, but the building sector is not the answer, it's not the place to use it, and it certainly shouldn't be used as a smokescreen to delay electrification in buildings. Otherwise, we're going to lock up a lot of carbon use in our buildings, and we won't be able to get to our deep decarbonization goals. So with this, I think that's my last slide. I'm going to turn it over to Amy, and I look forward to the discussion. Thank you.
Great, thanks, Pierre. So point of clarification, I am Amy Ryder, but I'm actually here representing the Building Decarbonization Coalition. And so, although I also work for Archimede Consulting, just want to be clear about representation today, because for the Building Decarbonization Coalition, I am acting as their REACH code coordinator, which is why you get to talk to me about process. So that's going to be what I'm reviewing today. So if you'll go ahead and go to the next slide. And as Pierre eloquently said, I have an overly simplified version of this to show that because gas inherently has a variety of problems that we laid out there, but specifically just looking at the emissions profile, really the solution here to get to decarbonization of buildings is to eliminate the gas in those buildings themselves. And so that's really what this is showing over time, is as the electric grid cleans up, we'll have the opportunity to then also have cleaner buildings at the end of the day if we're building all electric now. So that's really the intent here as we continue to move forward. So decarbonization being the goal of our organization, it really comes down to electrifying buildings with efficient equipment that has flexibility for demand control and to enable an even more cleaner grid, I guess I should say. So to allow for 100% renewable electric grid does require some level of flexibility, demand, and storage capabilities. And so all of that is important for us to ultimately get to a fully decarbonized building stock. So today really is not entirely focused on the building code, but I think it's important to just touch on it briefly because when we talk about REACH codes, generally folks think that we're talking about the energy code specifically, and I'll explain why there are some differences in how cities are approaching this. But the building code is at large is really important, and then the energy code itself is a very common compliance pathway for setting new standards at city scale for buildings to electrify under new construction codes. And so as architects, and although I see several city staff on the list here of participants as well, you're probably fairly familiar with the energy code, but the new code did go into effect just January of this year, which although that feels like a lifetime ago at this point, is fairly recent. And it does not fully encourage electrification. In fact, has some limitations around building all electric homes that we are all working through. And this is part of why REACH codes at the city and county level have become so popular, moving the needle towards requiring or at least promoting all electric construction. So that's an important piece just to understand, as well as the fact that the California Energy Commission, who writes the energy code, actually has an established pathway for cities and counties to go beyond that code. And so I'll happily walk through some of the details of that. I'm seeing some of the folks who are in the process right now popping up in the chat window. So we'll get to you. We'll let you brag. No worries. But there's definitely precedent for the energy code in this way, going above and beyond, and really pushing for electrification specifically, so we can start to get at the emissions limits within buildings themselves. So 3 important things for everyone to recognize, though, as REACH codes come forward, and this is often a point of contention for the conversation that Matt will be leading later when we're talking with stakeholders, but what really is required when it comes to REACH codes? And first and foremost, the state requires that cost effectiveness is part of the equation. And so that's a really important thing to know up front, is that there have been studies actually conducted for the entire state looking at electrification compared to standard construction, which we call mixed fuel typically in my world of REACH codes, and that the solutions that we're talking about today are found to be cost effective across the state, regardless of your climate zone and in building types of all kinds. So that's certainly an important thing to keep in mind. One thing, however, that's a little bit more nerdy is about preemption, because the federal government actually gets to say which appliances can be installed in terms of their legal minimum efficiency for simplifying manufacturing processes. There are some limits on how prescribed specific appliances can be. So that also is addressed though by the cost effectiveness study. So in fact, all three of these are not problematic. They're just elements that you should be aware of when looking at REACH codes under the energy code, because certainly the last bullet being rather important, buildings are required to be more, or at least no more energy use type buildings when applying under a REACH code. So that's just a quick synopsis of some of the elements that are required to adopt a REACH code through the California Energy Commission. So what does this process look like? I wouldn't say straightforward for everyone, but we will get to how many folks have actually gone through this in just a moment. But they do try to make it fairly prescribed and straightforward in terms of how to get there. The toughest one for sure is engaging with community stakeholders, which is why meetings like this are so vitally important to really understand what does all electric construction mean and how can you go about making it happen in your design work. So engaging with stakeholders and refining exactly what's right for your community. One of the nice things about any kind of local code is that you have some ability to adjust slightly within the range of your personal community's flexibility. Like, what is your community ready to do? How far do they want to push both your elected officials as well as your building community? So there is some variability of how these are manifesting at the city and county level. So from there, city staff are really taking on the charge of engaging stakeholders and then presenting to their elected officials for adoption. Just like any other ordinance, there is a requirement for first and second readings for adoption. And so there's public input throughout that phase of the process. When you get to the middle section, however, the public input changes because it goes to a statewide level, but at the California Energy Commission explicitly, that really is more of they're making sure you checked those three boxes from the previous slide. Did you in fact consider cost effectiveness? Do you have any preempted appliances required? Are there any problems administratively? So that problem, although that step of the process, I should say, is not generally a problem because it really is administrative in nature. And then the fun part is getting to staff training and implementation and continued implementation. And that's where a lot of the cities who have already undergone this process are today. So one thing just to keep in mind is local governments do have quite a bit of potential for influence. And the REACH codes generally that we're talking about under the construct of today's conversation fall into the category of construction, and it falls under codes and permits, less so for entitlements. But the initial construction is really what most REACH codes are after at this point in time. Local governments do have the power to permit renovation projects as well, and there's certainly growing interest from many local governments to see where electrification can be promoted in that arena. But local governments also have the ability to approve at the planning scale. So they can change zoning ordinances, general plans, etc., as well as some of the less common options, which is really starting to impose restrictions or requirements, it definitely varies of how it's done, but some sort of time of sale requirement for when transactions go through the real estate process, changing hands. And then occupancy permits. This seems to be a growing area of interest, especially related to rental licensure, and where the apartments and houses and other kinds of residential rental properties will actually have to undergo some sort of local government process. And that is a potential place for influencing electrification as well. So just a quick overview of some of the most common approaches, and actually, frankly, 2 out of 3 of these are common, and the other one is not at all. But we'll give you a sense of some of the things that local reach codes are looking at with regard to electrification right now. The orange column, being the future-focused all-electric, is commonly called the Berkeley approach. This is where no natural gas hookups are allowed in new construction projects. And you can see at the bottom there the impact to the greenhouse gas savings. These are preliminary numbers, certainly based off the cost effectiveness study, but they are relative in nature, so hopefully still valuable from that perspective. The middle column, the emissions focused electric preferred, is really about giving the nudge to the code itself toward electric construction. So this is around actually imposing additional requirements on mixed fuel buildings or buildings that use natural gas, and not imposing those additional efficiency requirements on any all electric construction projects. So this is a popular because it still allows for both options, but it starts to turn its focus toward electric construction and try to prioritize that within a community. What we're not seeing much of is the efficiency focused. So the green column on the right-hand side there is the more traditional approach of a reach code. If you've heard of reach codes in the past, they have largely had to deal with both energy efficiency and green building, and not so much electrification. And there are very few cities who are undertaking that particular approach now that electrification has become so popular. So few that we don't even track them at the Building Decarbonization Coalition. So when I talk about how many numbers of cities have done various actions, that's not even included in our approach. So where are we? We are climbing this hill. It's rather impressive, actually, for any of you who have dealt with reach codes in the past. It's unusual for there to be very many, but in 2019, from starting with Carlsbad, California in February of last year, through today, there have been 30 local governments who have passed some form of electrification preferred or required ordinance. So that's a pretty exciting number, and certainly why we're continuing to have these conversations, because there's just so much momentum. Now, what does that look like? That is broken down across the different local governments. Surprisingly, certainly from my perspective, I did not expect so many to go all electric as the only option. So that about half of those cities have actually required all electric construction for some building types, mostly in the residential sector, but it's not only residential who have gone to no natural gas is allowed in new construction. Again, the Berkeley approach, or the moving towards natural gas infrastructure moratoriums, is the blue slice, the smallest piece there, and then electric preferred makes up the remainder. About a third of the cities have gone with a preferential treatment to electric only construction. So I think that's pretty fascinating to see how cities have chosen to adopt and move forward with all of these various options. One thing I will note is that the blue slice here in particular is not through the energy code. And so it has slightly different requirements, but it also has a little bit more flexibility about how it's implemented. But the process generally is the same, where talking with you all and getting stakeholders on board is part of that process. So from the external side of architects and designers, You won't see much of a difference if they're going for a moratorium at the city level, but city staff, there are some pretty significant differences that should be considered for those approaches. And then this is just a quick snapshot. It is certainly not all inclusive, but I wanted to represent that there are not only a lot of cities, but there are a lot of different ways that cities are approaching this at a more granular level than even the pie chart previously can really explain. One of the more popular approaches of the all electric is really focused on the specific system. So again, starting with Carlsbad, they adopted water heating, electric water heating only as their first step of their ordinance. Many others have said that electric water heating and electric space heating are required, but have left fireplaces and stoves out of the equation until we can build consumer demand for those things as well. So in those cities, they chose to go what might be perceived as a slightly easier route, but I think is still a very viable solution for getting those big emission generating devices out of the homes. So those are, again, this is just a snapshot. I will also point out that many cities are opting to have additional solar and electric vehicle requirements as part of their codes and try to move the needle in those ways as well. So there's lots of different ways to approach ordinances when it comes to moving toward an all electric construction future. And I've just put our contact information here. We do have support available for local government staff who are taking on this charge. Feel free to reach out to me. Thank you.
Great. Next slide.
I just want to also let everybody know we have Matt and then Scott. So just let you know where we are in the process. So we have 2 more speakers, panelists, and then we'll get to the questions. Please keep putting them in the chat box. I'm tracking all those, so thank you.
Great. Thanks, Jed. Hello, everyone. My name is Matt Goff. I am a senior campaign representative with the Sierra Club. I work on building electrification at the city level. So I work both with local advocates and volunteers to help them develop their strategies and tactics to support electrification in their communities, as well as working with city staff and elected officials to help them think through the policy solutions that make the most sense for them. So today I'm just going to walk through a couple of things briefly. I'll talk a little bit about some of the harms of gas and the benefits of electrification. I'm going to go through the policy landscape in California, and then zoom in on some city-specific examples, and then talk about what cities can do and how folks on this call can start to plug in and make an impact on these issues. So on this first slide here, I'll just touch briefly on some of these points that have already been raised. There are a number of reasons to electrify our buildings outside of climate. So on the public health front, I think Pierre covered that quite well. One statistic that sticks in my mind and I think is worth sharing with this group, that UCLA study that was done has shown that children who grow up in homes with gas stoves are 42% more likely to develop asthma when compared to children who grow up in homes without gas stoves. So there's an important public health element to electrifying. Safety is another big concern. As climate change gets worse, we know that homes with gas infrastructure are more vulnerable. And in the instance of a thing like a fire, your home is more likely to catch fire or explode if you have gas infrastructure in it. On the flip side, for why we should electrify, it allows us to support clean energy and renewable energy, something that California is already moving towards. And electrifying our buildings supports that transition towards a carbon-free future. There are also benefits in the job space. So the Sierra Club supported a study that was done by UCLA and UC Berkeley. And it found that in a high building electrification scenario in California, we could add over 100,000 new jobs to the economy. And that's even accounting for the jobs that were phased out of the gas industry. And these are high road, high paying jobs. So there's a future that brings in more people through electrification. And then there's the affordability portion of this. So we know that building with all electric new construction is cheaper than building a mixed fuel building. And because of the ultra efficiency of heat pump and induction technology, homeowners and renters can save money on their monthly utility bills. So there are a whole host of reasons why communities should electrify. So let's go to the next slide here. To zoom in a little bit on California, I want to start with sort of where we are now and then where we hope to go. Bad news first, California is a gas-heavy state. 90% of the buildings here in California use gas, and that's largely because we have had policies for decades that favor gas heating in buildings. Now, the good news here is that the tide is starting to change. We are seeing a number of policies come out of our regulatory agencies and out of the state legislature that can support electrification. So rebates to lower the cost of electrification, electrification pilots in communities across California. We're seeing changes to the state building code that allow for all electric new construction. And we're seeing utilities start to think through electrification friendly rates. So next slide. So then just to zoom in a little bit further, like what specifically are we advocating for? So new rebates for technologies like heat pump space heaters and water heaters and induction stoves, inclusive financing so that more folks are able to get this technology, both at the point of construction and for individuals who are looking at making individual changes, and then rate reform from the utilities to make electrification even more competitive than it already is. Another opportunity in California is to stop expanding the gas system. So we have really ambitious climate goals. We're trying to get to carbon neutrality by 2045. And so changes to the city and state building codes for new construction to be all electric help us get there. We also know that California is in a housing crisis right now, and electrification done smart can help to alleviate that pressure. So we need to be sure that we're advocating for no displacement and for rent protection for tenants. And we need to make sure that we're centering low-income renters so that electrification is distributed evenly across the state. A managed transition is another important policy platform that we're thinking about. So as we move towards a carbon-free future, we need to think about those gas workers and those people who are currently in the gas system and what their future looks like. So how do we prioritize and protect workers and Californians of all stripes? So next slide. Another big important consideration is sort of equity and justice at the center of building electrification. So this slide is highlighting a study done by Greenlining, which is an environmental justice organization that has done some really great lead thinking on what equitable electrification can look like here in California. And these bullet points are just some of their top line findings. And so I just want to reiterate them now. So focusing on the health impacts of electrification, community resilience, improved housing, and lower energy bills is an important thing to think through. We need to make sure that as we're designing this policy, we are talking to affordable housing groups and community equity groups to just understand the issues that they are struggling with, so that this isn't sort of a top-down policy solution that we're handing to folks. It's more of a collaborative process that benefits all Californians. And then some of these things to watch out for. I think one of the ones that stands out most to me is the cost of stranded gas assets falling on those who can afford it least. So as California moves away from gas, the customers who are remaining on the gas system are going to be paying a higher rate for their gas, and we've got to make sure that those customers are not our most vulnerable. The other thing that we need to make sure that we're watching out for is missing capital investment cycles in some of these communities that are not at the forefront or not as wealthy as some of their coastal counterparts. Next slide. So that's sort of the statewide framework. Now let's talk a little bit about how city leadership plays an important role in state policy. So as Amy mentioned, over 30 cities and counties now have passed, or excuse me, exactly 30 cities and counties have passed building electrification policy over the last year, which is incredibly exciting. This is important for a number of reasons. So cities can set high benchmarks for other communities who are looking at electrification. And so if the bar is here because of the work that was done in Berkeley or San Jose, the next tier of cities can build on that and go even further in their efforts to incentivize electrification. So it creates competition between cities for who can adopt the most climate friendly and housing affordability friendly policy. City leadership also plays into our strategy to influence the California Energy Commission. So we want to show public support for building electrification to improve Title 24, and so city leadership goes a long way in doing that. And in order to have these cities pass policies, we need to make sure that we are bringing a wide variety of stakeholders into the process. So that's part of why I'm really excited to be on this call today. I think that architects and builders and developers and engineers have played a really important role in the victories that we have seen in mostly Northern California to this point. And if we want to continue electrification in Southern California, we need folks on this call to advocate in the same way. So I'll talk a little bit more about that in some later slides. So we'll go next here. So what policy approaches can cities take? So Amy touched on these, so I won't spend a ton of time going through this, but reach codes are one pathway. A all-electric ordinance or gas ban, like a Berkeley-style approach, is another option. Another place that we engage is in climate action plans and climate action plan updates. So as cities are thinking about how to become greener, we can include language around building electrification. Another interesting policy solution coming out of the East Coast are emission standards for large existing buildings. So this is looking at how you can have a lowering cap for total greenhouse gas emissions from a large building over a number of years. And at a certain point, it makes sense for that building to swap and to replace its gas appliances with electric appliances to meet those new standards. Cities can also play an important role in pushing for state action. So mayors of cities or city council members writing letters to the editor, or lobbying in Sacramento, or showing public support for electrification can help to show the governor and the regulatory agencies that this is something that has broad support here in California. Next slide. So how folks on this call can make an impact in their community. So we need you to get involved. So how can you actually do that? If you want to get really deep and in the weeds, cities are hungry for folks with your technical expertise to help guide them on this policy, to understand what is currently feasible and what they should be including in their policy. So lending technical support to cities when they need it is a useful thing that people on this call can do. Making public comment at city councils or a virtual public comment, now that we are all online thanks to COVID-19, is another great way to educate elected officials on what this issue is and how it can work, and how in your professional experience it's viable and makes sense for your community. Having folks on this call also engage in media work is valuable. So writing letters to the editor for your local paper can help to raise the visibility of the issue. Writing op-eds is another great way to educate folks who are reading the newspaper or listening to the radio about the benefits of electrification. Talking directly to reporters to answer their questions from a technical perspective is quite valuable. And then just doing grassroots advocacy. So if you have time to do organizing in your community, that can go a long way. So sending petitions and letters to council members is valuable. Recruiting your friends who might be in the builder and developer industry to also get involved can make an impact. And then organizing public events. So I want to just sort of finish this off by talking a little bit about the city of San Jose and how they included a variety of stakeholders to have a successful REACH code adopted. So San Jose is, I think, the third largest city in California. It has over 1 million people who live inside it, and it has a very diverse building stock and a lot of new development planned. San Jose passed a really great REACH code. It has got all electric requirements for low-rise residential and high efficiency requirements for high-rise residential that steer builders and developers towards all electric. San Jose was able to pass this code because the coalition there made sure to include a wide variety of stakeholders. So at the city council meetings, when this issue was being discussed, we had folks from health industries, so doctors and nurses, talking about the benefits of electrification. We had our local utility, PG&E, send representatives to talk about how the system and the grid could handle this load. We had labor, so a local IBEW chapter came out and voiced support for electrification. There were health groups, there were environmental justice groups, there were builders and developers. To the city council, it appeared, and it was true, that the community was behind them on this issue. And so we were able to pass some of the strongest legislation in one of the biggest cities in California. And as we look to Southern California and try to replicate these policies in communities here, we need that same robust coalition. So I hope that folks on the call today will plug in. So we'll go to my last slide here. And I'll just say that if you decide to get involved, you're in good company. There are a number of organizations who are already engaged in this work. And so I hope that after this call, you'll follow up with me and Amy and Pierre and Scott to learn more about what you can do to make an impact.
Thanks, Matt. Hi, everybody.
Oh no, Scott, your audio again is doing that. It's not clear again. Do you? Are you able to call in on your phone?
Yes, I can do that. My apologies here.
You have your Darth Vader song on, Scott.
Yeah. As he's dialing in, we're taking a lot of questions here, just where we are. Scott, once he gets dialed in, will be our last presenter. I hope we're budgeted till 5 o'clock. Well, I don't know if we can go over that by a little bit. Seems like we might need to.
Yeah, technically we're until 5:30.
Oh, sorry, 5:30. I thought, okay, so we got time. All right. So when Scott gets on, we'll just transition over and keep, if you haven't, put your comments, keep the comments coming in the chat window. That's the easiest way. And I'm basically making notes in my pad. All right. So with that, unmute yourself, Scott, and let's hear you.
Okay, can you hear me now? Yes, okay.
Yes.
Hi, everybody. Sorry for that technical glitch. So like many of you, I'm an architect. I'm a principal with the HCD. And one of my big focuses for almost 20 years now has been designing zero energy buildings. We're very proud of that work. It's been lots of fun. We've had some visionary climates. But if we stop and take a hard look at it, the numbers of zero energy buildings is still just really tiny. And our climate crisis is really one of speed and scale. So I started looking for a way to plug in at a policy level, and it's new to me. I haven't really known how to do that, or haven't been a part of that before. And I got connected with the other folks on this call a couple of years ago when this all started, and they kind of gave me an infrastructure to plug into. And so I didn't feel like I was out there just flailing around, you know, not knowing what I was doing. And it's been one of the most exciting, fast changing things I've ever seen. Next slide. Earlier this year, the AIA California, the board endorsed the Zero Code. They realized that these voluntary efforts at zero energy, low emissions building, while great, were not getting us where we needed to go fast enough. And so they endorsed that every new building should be a zero energy building. It's an astonishingly bold goal. On the other hand, if we look at it not as architects trying to do this on our individual buildings, but we look at it in terms of policies that we can pass, it's happening today already in a few places. The spreadsheet of cities that Amy showed, of 30 cities or counties that have passed these electrification codes, about a dozen of those already have 100% clean power today through their community choice aggregator power provider. There's also a dozen or so cities around LA that have opted in to clean power at 100% renewable energy. So if you combine that with an electrification code, you get to what we architects have been calling a zero energy building for every new building. It's astonishing. I think we didn't really look at it from that policy level. We looked at it at the individual building level. And so, you know, today this is kind of a call for you to join us and to join the AAA Committee on the Environment in helping to advocate for these. Next slide. So when I got involved with this, you know, I have to sign sets of drawings, just like many of you do. And that means that we're responsible for those drawings. And, you know, if something goes wrong, we get a phone call, or even worse, a letter. So the first thing I did was I met with 7 of the top mechanical engineering firms that we work with across the state. Many of you will know these people or these firms. And I said, hey, folks, is our industry ready to go to all electric buildings? You know, is this something we can do? Does it make sense? Is it affordable? Is it good for our clients? Can we stand behind this? And what they said, with very few exceptions, was yes, our industry's ready. The link at the bottom, you can read some of those interviews. This was a 1.5 years ago, and a lot's changed since then. Next slide. So here's what some of those folks told me. Hormoz at Interface Engineering, they do lots of commercial and higher ed work. Hormoz said almost all our projects are all electric. I only use gas when the client makes me. Electric is almost always less expensive or cost neutral. Next slide. MITHUN is doing a number of large multifamily housing projects in the Bay Area. And Malcolm Harris, the principal there, he said, we have a large number of these projects, and I'm a huge, huge fan of this change to all electric multifamily housing. It's better in every way, a great simplification of the system. It's less expensive, higher performance, less maintenance, and more sustainable. Next slide. Those of you who work at in higher ed, we do a lot of that work. We do a lot of work for UC. David Phillips is the Associate Vice President for Energy and Sustainability. As many of you know, they put in an all-electric policy for new buildings for heating and hot water last year. And they're prioritizing all electric new buildings. And then they're looking at starting to retrofit their old buildings. Point Energy Innovations did a detailed study that showed that the costs are comparable, both on the construction cost and on an operation cost for labs and for academic buildings. And for residential buildings, they're cheaper, both on the construction and operating cost. Next slide. One of the things I've done is people keep saying, oh, well, can you do this project or can you do that project? So I've called on my colleagues, and I'm calling on all of you, send me your all-electric projects. And I put them together in a slide deck that looks kind of like this. There's probably up to 100 projects now of all different project types. And then somebody says, oh, I know UHD or I know Integral Group. I can call them up and ask them how they did that or what they think. And it's been very effective. So there's a link to on the next slide, you'll see a link, second from the bottom there, examples of all electric projects. You can click on there and see a whole bunch of projects. If you have questions about them, you can contact people. A shout out to the William J. Worthen Foundation. They're writing this design professional guide to decarbonization in the built environment. It's in the draft stage now, and if you would like to make comments on that and review that, you can do so here at this link. And also just a few other helpful guides. So if you'd like to get involved on the AIA Coat advocacy side, let me know at my email there. And thanks everybody for joining us. Back to you, Jed.
All right, thank you everybody. That was a lot of information, and thank you everyone. Trying to think if I should keep sharing my screen or if we should. So I've gone through some notes here, taking notes, and basically I'm just going to go back through some of my notes. When you hear your name, take yourself off of mute and present your question to the panelists. I'm just going to go in order as the questions came in, and if you feel like your question was answered, just let us know. We'll move on to the next one. Deborah Gregory, I think, had a question about what to do with all the existing equipment, all the existing gas stoves, and can they be converted or something. So Deborah, are you still on the call?
I'm here.
Excellent. So do you want to maybe define your question a little bit better than I did?
Yeah, I think it was maybe 2 or so years ago, I was at a food and water watch meeting and they talked about this, and I thought, well, what the heck is going to happen with all those appliances that we have? Some of you have answered a few things, but maybe there's no single answer. I don't know. I don't know who would have the answer even.
Yeah, just anybody on the panel, if they want to try to take that, or if it's, are we stumped by this question?
Yeah, I can make a stab at it. I think there are average lifespans published for a whole bunch of different appliances, and you know, they generally are in the like 13 to 15 year range that most appliances, you know, live before they get sent off somewhere to be recycled. You know, the metal obviously can all be recycled. So I think we anticipate a lot of this stuff just to be done during a normal normal end of life renovation, kitchen renovation or something like that. Or, you know, most people aren't going to replace their water heater early. They're going to do it when it burns out, essentially.
Thank you.
Thank you. Tom, I didn't write down your last name. I had a question about gas cooktops, or a comment about gas cooktops as well. Tom, are you still with us?
Yes, I am. But I was just making the same basic point that Scott made, and that is that we can recycle the old devices. And really, it doesn't make sense environmentally to keep riding a water heater that's more than 5 years old, a gas water heater, just waiting for it to fail and flood something. It probably makes sense once you understand electrification to go ahead and electrify it in midlife. You're not doing the environment any favor by trying to ride that old gas water heater into the ground and the climate out of existence.
Awesome, thank you for that. And someone, I think Allison Kendall has a success story, Culver City. Do you maybe want to share like 1 or 2 points about your project in Culver City? And that's exciting.
Sure. Yeah, we developed this. Frankly, the idea started in the last recession when I took advantage of some of the training that was offered through the ERA Act around energy efficiency, and became aware of just how many downsides there are of gas appliances, both water heating and cooking, the significant safety issues and so on. And so when we got this opportunity to do a new construction townhome project, very space efficient in downtown Culver City, we decided to go all electric and essentially to try to meet the new code in advance with a net zero energy project with photovoltaic, but avoiding all the costs and safety and environmental issues of gas appliances. So we have heat pump, which we specify for all our retrofits as well, and additions, converting people from gas furnaces. And we have heat pump water heaters, which are kind of expensive. That's the one thing that's probably a little bit of a tough sell. As well as induction cooktops, which people are coming around to. So we think this is definitely the way to go, and really not much of a sacrifice and not much of an extra cost at all.
Yeah, that's for at the AIA Los Angeles Community Environment. We had a presentation as well about hot water heat pumps, and I'm glad that we're talking about that in this kind of with so many people online, because I think it's really understanding that technology and designing it well that is one of our solutions. And I think as the industry goes forward, the prices have to come down. Everybody who installs them and the maintenance that's associated with it, everybody has to get educated about that. And I feel like not enough builders, designers, or clients and developers understand what this technology is. And it seems to be, I'm hearing it over and over again in all these forums I'm part of, and it seems to be a critical pin. So thank you for that. I'm going to move on because I think, Michael Malinowski had a comment that I think is relevant here. We've talked about gas. It was brought up about how, gas and electric, and I think that, there's black and white arguments, but there's a lot of gray between them. And Michael, if you're on the line, I think, your comment about a long transition period or a transition period, do you maybe want to expand on your comment and present that? I think we have the right people here to speak to this idea of a transition period.
Sure, thanks, Jed. Really, it's just about, I've seen studies that show that there's going to be some real damage to a lot of people if the transition away from gas occurs over a long time frame, because all that infrastructure still has to be maintained. You'll end up like in Detroit, where you have a couple of houses on a block that are gas. In Detroit, it's a couple of houses occupied and the rest torn down, but you still have to provide all the infrastructure, police, fire. With the gas network, it's already been poorly maintained. We all know that. We have a bankrupt utility that's operating most of the gas systems in California, and it's a real challenge. I think what's happening right now with the REACH codes is great. I'm actually working with AI California to help figure out a way to couple the move toward electrification and REACH codes with the zero code for California that was developed by Architecture 2030, which really is focused on shifting to renewables. And I'd really, rather than get bogged down on this dilemma of what do you do with the gas infrastructure, I don't know that there's an answer to that. All the reading I've done, I don't believe it has really been figured out yet. I'd rather hear from, there's so much brain power on this call. It's pretty unbelievable. What do people see as the connection between the efforts of Architecture 2030 and their work on the zero code and the movement toward renewables, much of which is actually already happening in California with this electrification? Because the AIA California has already endorsed the zero code, but now we're trying to figure out how all these parts and pieces fit together. So I'd like to find out if anybody has any thoughts on that. Scott actually is working directly on this issue, so he and I have had many sidebar conversations, but I'd like to hear if anybody else has any thoughts.
This is Pierre from NRDC. If I can just take first a stab at this. So thank you, Michael, for I think both insightful comments and questions. On the gas infrastructure, there's no silver bullet, but there are ways to plan for the transition so that we mitigate the stranded cost issue, right? So if we stop making investment in new pipelines, in new buildings, that will get stranded before the end of their life because they will no longer be used. That's a way to limit how much we're going to have to pay for the remaining infrastructure. And at some point, when we have the ability to electrify entire neighborhoods, I don't think we're there yet, but I think we're moving towards that as the technology cost comes down. We'll be able to take out, targeted parts of the infrastructure so that we don't have a kind of organic, movement away from the infrastructure with less customers and still the same amount of infrastructure to maintain, but you shrink the infrastructure as customers exit the infrastructure, you reduce the cost. So that's the goal. It's not easy to do, but the first thing we have to do is stop digging the hole, which means stop building new buildings with gas so that we don't have stranded infrastructure. And there's a lot of planning, and the earlier we start with this planning, this is not going to happen tomorrow, but the earlier we start, the more avoided cost we can get and the more we can make that transition easier, which is something that we can start doing right now. On your question, I think on the second question, which is what's maybe the nexus of the zero code and our decarbonization efforts, I think they really work well together because zero code is around having clean energy in the building and as well as efficiency. And when you combine that with electrification, you get to that zero carbon or zero emission building. And Scott made that case early on. And when you do that, not just at the building level, but at the neighborhood, the city level, then you have scale and you can drive these zero carbon buildings at scale through efficiency, renewable electricity, and electrification. So I think, to me, that's really, these efforts go hand in hand. And I'm just, no, before I pause and hand it over to somebody else, I'm just going to take advantage of having the mic. I want to emphasize one thing that Matt said is around how the comments that Scott has been making at every single council meeting along the lines of what he presented to you today has been absolutely so game-changing in terms of city council members being able to hear from an industry expert and insider about the feasibility, about the economics, about the readiness of the industry, and how this has changed the conversation of so many council member, city council meetings about, you know, making council members feel confident that this is the right thing to do, that this is feasible. It's not just, you know, environmentalist requests. It's something that makes economic sense, that the industry is ready for. So I would, you know, encourage everybody who's interested in doing something similar is to use the slide deck, either Scott's or your own, and just, you know, take the message out to city council members and to stakeholder meetings around industry being ready for it, ready to go, and how does this make sense for not just for the environment, but for the economics and the business as well.
Does anybody else want to layer in on this question?
Yeah, this is Richard.
Go for it, Richard.
Just echoing what Pierre said, but expanding a little bit on the private capital side of perspective on stranded assets. This conversation has been a little bit talking about public policy, so we tend to think public sector solutions, and that's important. But the private sector has and will continue to fund many of the solutions needed to get us to electrification fast and faster. And those who are left sort of quote unquote holding the bag on that particular set of investments in that particular infrastructure may require a bailout in the end. Look at it like the last 5% on the gas line all get free induction stoves and get converted to electricity because they're the ones who are going to be most impacted by climate, you know, equality anyway, right? Because everybody else already bought one. So I think that there's a combination of public-private solutions, but definitely there will be hundreds of billions, if not trillions of dollars invested in the new green economy in the 21st century.
That is great. I think that talking about that point of view from the investment side, from the private side, is critical. I'm also part of Passive House California, and we're always talking about, like, is it the chicken or the egg that comes first, right? Like, you know, who do you speak to, and who ultimately can take the action first? And that's where I've always kind of like struggled with. And I think in this presentation today, what you've kind of outlined is like there's been a lot of clear, maybe bottom up of, like, you know, us as architects and us as the advocates coming forward, but it needs also be, and I would call that I don't know if we're the chicken or the egg, I don't know what we are, but I think it also has to be flipped over as well to the client developer, you know, ownership side as well. And we need tools and to educate them and really get them to benefit from it as well, from first cost to investment and return as well. Is there something else you want to, you know, am I reiterating that well, Richard?
Yeah, and I think market forces are already having that happen at the high end, right? Whether it's luxury condos or high-rise towers, the economics are driving them to the most efficient systems possible. We'll continue to see a trickle down of innovation, you know, to mid tiers and later tiers. And maybe part of the solution here is also access to credit to fund what is a capital investment in infrastructure, whether it's behind the meter at your house or up on the hill in the desert on the grid, that's going to expected to last 20 years or more. With that, I'll let you take it out.
That's good. All right, do the panelists, any panelists, I think this is a great subject. Any panelists have additional maybe thoughts on this or insight on this side of the conversation?
Well, the only thing I would add, just to echo Richard's point on, you know, private capital being ready to jump in, we know that the manufacturers of heat pump equipment, whether it's heat pump water heaters, heat pump space heaters, are really watching and engaging in California because they see the policy signal we have about $500 million in incentive in the works in California. They're not all available. Some of them are available already for different technologies, different types of buildings, but there are a number of programs. There's 2 laws voted by the California legislature 2 years ago that are being implemented by the Public Utilities Commission right now and the California Energy Commission, which are going to become available early next year for both new construction and also existing buildings, changing out for heat pump equipment in existing building. And the goal is not just to buy it down to make it cost effective. That's one goal. The goal is also to build volume and capacity in the industry. And we're already seeing the manufacturers, A.O. Smith and Rheem and Mitsubishi and Carrier and all the other heat pump technology manufacturers invest in developing the supply chain in California, invest in R&D to bring to market the products that we need in California, like the plug-in 120-volt heat pump water heater. So you don't have to retrofit a conduit and new wires and maybe upgrade your panel. You just plug it in, drop it in and plug it in. So this is a type of innovation that's going to be driven by this policy, by these incentives that we're seeing coming. We're just at the beginning, at the cusp of this innovation, and we need early adopters to keep the manufacturers interested and make sure that there's demand that builds up at the same time as they're working on the supply side.
That's perfect. Can I follow up with you on that afterwards? That'd be perfect for a project I'm working on for Green Building Council LA.
Absolutely.
Thanks.
Exciting. That's why we're here, to connect and connect people that don't normally are in the same room at the same time. So that's very exciting. I also want to I had in my notes here as people were sending in comments, Nick Brown, you were talking about Southern Cal Edison electrical rates, and I feel like the electrical rates and you're talking about prime rates, and I don't know, can you maybe expand on your comment and share that with the group, or if you're still with us online?
Sure.
Okay.
I was glad to hear Matt bring up rate structures, because I'm bringing up a slide here from one of my presentations. Can you guys see that?
Yes, we can. Thank you.
This is SCE's normal time of use rate down here in Southern California. You can see even off peak, you're paying 25 cents per kilowatt hour in summer and winter. If you go now to the prime rate plan, you've got slightly higher rates in peak period, but fantastic rates, 15 cents, 14 cents for most of the day. Those are fantastic for running a heat pump in winter heating season, as well as running it in summer cooling season. And you can program a heat pump water heater to coast through that 4 to 9 p.m. period in many cases. So I wanted to mention that. And when I run an energy model using a mixed fuel house on the one hand and an all electric house on the other with that SCE prime rate, the savings can be $200 a year in utility costs. So I encourage you all, shameless plug coming. I'm teaching that class May 27th through AIA, LA, and Long Beach. Love to have you along. We cover the why all electric, the how all electric, and the energy modeling piece. And then we're repeating it again for Drew at Santa Monica. I see his face down there, so in June.
That's right. And Nick, if you could email me, the AIA committee, LA Committee on the Environment has been talking to the Long Beach Committee on the Environment. So if you could just email me some of the stuff, we can promote these through our newsletter as well.
Jed, before we go to the next comment, I just want to take a little time to salute those on the call, and Drew in particular, who've been leaders on adoption of the REACH codes. And I don't know if we have others on the phone here, but I think we can all salute leadership. Santa Monica was one of the earliest cities to go forward with electrification, and it's hard to be a leader, to be one amongst the first. You don't have 25 or 29 cities that have gone ahead of you, and so just want to salute Santa Monica and Drew's leadership there.
Does Drew want to say something and maybe give us a little insight of this?
Hello, everyone. I'm here with Dallas Sustainability in Santa Monica. I mean, I just want to thank Amy Ryder and Pierre. Oh.
Lean into your microphone.
I'm unmuted.
There you go. Yeah, we can
Okay.
hear. Just lean into it.
Okay. I'm with the Office of Sustainability. I want to thank Pierre and Amy and the folks at the Statewide Codes and Standards Committee. Yeah, our REACH code has been in effect since January 1st. We've already had quite a few applications come through. We require a certified energy analyst to be on the project team. So this is someone who's an expert in Title 24 modeling. And we have an electric preferred REACH code that can be found, just Googling Santa Monica REACH code, preferring all electric. And yeah, we have an event coming up. Nick's going to be teaching a two-day event on all electric construction and how to model all electric buildings. So hopefully y'all can attend. And I'm available to answer any questions. My contact information is on the City of Santa Monica Green Building website.
Thank you. Isabel, Divider, did I already mention this? Did you speak about solar thermal? I think there's a question like, where did solar thermal go in this conversation, right? You want to maybe expand on that?
Yeah, there's such a huge demand on my rooftop. And for a lot of times, a lot of projects we're trying to do more green roofs. So I'm wondering what happened to solar thermal. You don't hear much about it. You can put it on the sides of buildings, on the roofs. And Tom actually did answer, so he might want to step in and submit his answer. Thank you.
This is Tom. Yeah, so I started my career as a solar thermal engineer, and what I realized was there is a lot of labor up on the roof trying to get the water plumbed up to the roof and run through solar thermal panels and get all those pipes sweated together, soldered together so they don't leak, and then wrapping insulation around all those pipes. And then you also have to run an electrical system, electricity to the pump and electric sensors up to the panels and all that. So there was a lot going on there, a lot of labor. And really what's happened is the economics of photovoltaics and solar thermal have inverted dramatically, with factory built photovoltaics becoming the really cheap way to harvest energy off the roof, and solar thermal panels being an ever increasingly cost way to do it because of the increasing cost of labor. So, I basically see that now heat pump water heaters with 1 or 2 extra PV panels are the low cost, low carbon way to heat water.
I think that's interesting because in this conversation, we always lean and you jump from like one technology to the next. Also, as an architect, I can agree there's a lot of stuff happening on the roof. It's not just this flat surface that's empty. I feel like there's almost more activity on the roof than some other surfaces of the building. Do any of our panelists have any comment or additional conversation about solar thermal in addition to just solar photovoltaics?
I can just say in our experience, we've seen a lot of projects that had problems with their solar thermal, and solar photovoltaic has just been dead simple, rock solid, no problems at all.
Thank you.
I just want to add that you could integrate green roof and solar panel and get more benefit out of it, because the green roof actually cool the underside of the panel and help boost the electricity production.
I like that, Teresa. I remember years ago, that was our conversation like 7 years ago, right? Weren't we supposed to like green every roof in LA? It's always just like kind of like this conversation keeps shifting. we're here talking about decarbonization, but I think we have to remember some of the other policies that we've been focusing on in the past and layering them together. I have a note on here, but I don't have the question. Kalam Chung, am I saying that right? Cheng, are you on the line, and are you still able to share your question with us?
Yes, I'm on the line. I had some questions about cost effectiveness and also about the different cities adopting the REACH code, but Amy has answered my question in the chat box already. I'm good.
All right, we got parallel conversations going on. We got chat conversations and real verbal ones going on at the same time. All right. I think this may have also been answered in chat, but I took a note down that Karen Bragg talked about, COVID-19. Is this and how is that delaying any of these strategies? Does it? And what maybe can we do in this time when we're working from home? Even though, as we're having this conversation, a lot of people are going outside and reinstating engagement, but we still, I think, a lot of these public organizations still are not together. Karen, are you online? You want to state your comment about COVID-19 and its impact on these policies?
Yeah, I am online. I mean, one thought is like all the budget cuts that we're starting to hear about because the states and cities have less revenue. Like, does creating a REACH code, is that going to go on the back burner? I don't know. Does that cost a jurisdiction a lot of money? Or I guess alternately, would the pandemic and what we're going through would that potentially be an incentive that jurisdictions might actually move faster with some of these issues? I don't know if there's any thoughts or conversations that have already happened on this that people know about.
Yeah, I can throw in my 2 cents on this. I think that it just sort of depends from city to city. So for example, San Francisco is considering an all-electric ordinance right now, and we've heard that they're planning on introducing the ordinance language to the public in the next couple of weeks. San Luis Obispo is looking at moving forward on an ordinance. Oakland is looking at moving forward, Culver City as well. So I think in some places there is still an investment in adopting building electrification policy, but there are definitely other communities that are struggling with the budget impacts of COVID-19 and have put building electrification policy on the back burner. And I think that in some ways that makes sense, but in other ways, I think that we need to think through how to communicate the importance of COVID-19 in a public health crisis and in a potential recession. So on the public health front, studies seem to be showing that air quality can affect people's likelihood of getting COVID-19 and then the health outcomes that they experience. And so building with gas is a way to exacerbate health concerns from indoor air quality. And so electrification is a potential solution and something that elected officials should be thinking about. And then on the affordability side of things, we know that it's cheaper to build with all electric new construction. And so if we are going into a recession, cities are going to be looking at ways to mitigate the effect of less overall revenue, and building electrification could be a part of that solution. So I don't think that there's a clear trend line yet towards more or less electrification because of COVID-19. And I think that this gray zone that we're in right now is a chance for us to present building electrification as a solution. And I think that we need to be thoughtful and considerate and not put too much pressure on cities because staff are experiencing a lot of stress around dealing with this new landscape. But I think that the direction is unclear at this point, and we could steer it towards more electrification.
So that's great. So it seems like it's, as always, really important to help provide information to our jurisdictions.
Yep. This is Tom. I thought I'd share the experience in Menlo Park, where our staff developed kind of the truncated version of the REACH code, where they simply came up with, instead of a differential threshold of efficiency efficient buildings didn't have to be electric, but regular buildings had to be all electric. They said that would take more staff to administer that type of reach code, and that was the original proposal. And then they came up with the idea of, well, let's just truncate the mixed fuel use for space and water heating and go to electric for space and water heating. And that took less city staff and a strained budget to be able to just do the building inspection and see it more simply that, correct, you have no gas for heating and water heating, you pass.
Hey, Jed, I have a question for the group here. I see Andy Rauman and others on the call. I'm curious, what is the prevalence of electric in buildings in the Southern California area? Is it common? Are you seeing a lot of it? I'm just curious what your experience is.
Scott, it's still a challenge to get kind of every project to move along that way. We start out a lot of projects with the heat pump direction and things like that, and it just depends on if you can get the economics passed without, like, I like Jed's chicken and egg, you know, it's really carrot and stick argument. And with both, things move forward. With one, sometimes they don't move forward. That's the challenge. Showing the economics, as you know, like, that's really the key. You know, if code be damned if the economics work, right? So that's really where I think we as a community need to find the golden ticket is in showing that the economics work, independent of being required to do it from a code standpoint.
So, hey, it's Daniel. From a multifamily perspective, we've had clients, and talking about bigger stuff, have started moving to all electric some time ago because of the simple cost of running. All gas had to be separately metered, and you got all that copper piping that goes to the meter, to the house, back to the meter. It was nuts. And I did many all electric in terms of appliances. The rub is for water heating, for domestic hot. So I'm really interested to see if our clients are interested in developing the heat pump water heater, which I've been doing some research on, because in the bigger projects, they end up going with massive boilers on the roof, like multiple boilers. And sometimes they preheat, sometimes they don't. But that's the one that we have to work on, because the all electric appliances, as long as you're not getting into a quote unquote luxury discussion about I can't cook without gas, and I'm kind of joking about it, but it's a really big deal in rental housing. And go talk to the boys in Texas who are promoting gas all over the place. So.
A couple points on that. The other panelists talked about the performance of induction cooking, and SMUD did a bunch of consumer research, and they found that 90% were skeptical of an induction cooked up before they tried it, and 90% liked it after they tried it. So there is definitely a public perception thing there, but the technology actually is really good once people get used to it. There's also been, on the central hot water system, Pierre has been working really hard and a group of people on getting Title 24 fixed so that you can model that more accurately, and that helps the cost come down because it more accurately predicts it. Pierre, I don't know if you want to address that or not.
Yeah, I mean, it is a hot topic, pun intended, in the sense that the central heat pump water heating systems are still fairly new on the market. They haven't been supported that well by the compliance software in the code. But we are, the Energy Commission is working really hard with all the consultants to fix that. They already have provided some levels of solutions, and there's a phased solution that's coming in. So we will see more come into effect with more options in terms of technology over the next month or two. And the other thing is we're seeing a lot of manufacturer activity around providing better controls and better technology to support central heat pump water heating. So this is a very active field, and we're seeing an increasing number of central heat pump water heating systems go into new buildings at the moment. Definitely in the Bay Area, all the way to Seattle. Ecotope is one of the leading experts on this type of projects. And we expect that the rich code movement will help accelerate that, because a number of cities are now requiring for all new construction multifamily buildings to go all electric. So now they have to get it done, and this is going to be a forcing mechanism to make sure the technology and the expertise in how to use this technology, how to design it, becomes used more broadly.
And Ecotope is giving a presentation on Thursday, I believe, right, Amy, at the Building Decarbonization Coalition. And, Sean is a real expert on that, and maybe Amy can paste a link into that. If you really want to take a deep dive on that, he's your guy.
Yeah, I'll be happy to share the information with Jed, so we can and Will, so they can share with their people.
Yeah, Scott, this is Jed speaking. We do a lot of multifamily and larger projects, and I want to build on your question and just offer another architect's of what's happening in Southern California. Yeah, it's inside the unit. It's easy to have a conversation about removing the appliances and converting them over to electric. That is where the conversation has moved forward. And even to that point about as long as you're not in a luxury, and then if it comes down to metrics, is a luxury stove the critical element that delivers the quality of unit that you need? It's really I want to know more about how do we have that conversation about heat pumps, and I just want to understand, are we basing our success around this one technology? And then, what is the barrier, and how do we have a conversation with our clients about hot water and water usage in the building? I think that is the gap in Southern California in our projects. It's not the appliances. So I agree with, I don't have the answer. And I think that's in Southern California where we need the assistance, is bridging that gap.
The slide deck that I put together probably has, 30 multifamily housing projects in it that have central hot water. And there's as often happens, there's a group that kind of finds their design pathway through that and kind of refines it. And then that information and knowledge kind of gets spread around, and we're still in the early days of that. And so I think more sort of knowledge sharing and technical support is in order. I think the Building Decarb Coalition, the utilities, the CCAs, a variety of folks are providing technical support to design teams to help get there. And, I think finding some projects that are local and you can point to and you can assign consultants to that people can talk to has been an effective way to promote it in the Bay Area.
And then this kind of dials into Daniel Gangman, asking about the grid, which is also something I think I understand, but the question was, if we go to all electric, how is this working with the electric grid? Or is the electric grid as green as these buildings and vice versa? Daniel, are you on the line still, and do you want to expand on your question?
Yeah, thanks. It was just a matter of simple math, because I can't quote any statistics, but we're at some relatively minor proportion of the power that we consume in California that's generated from renewable resources. And I think the majority, if not the vast majority, is still coming from out of state, where it's produced with coal, even in some cases, or natural gas. And it's going to be a while to wean off that supply chain with the kind of squirrely utilities controls or not controls we have in California. That was my concern, is that, so we gear up all these buildings to be all electric, and they're all putting more demand on the grid. And granted, we're distributing the infrastructure with solar all over the place, which is awesome. But in terms of strictly grid and not distributed, that's where my concern is. And not saying that that should stop us from doing it, but I'm just saying that in the short term, I think it may actually increase carbonization rather than decrease it.
So maybe I can address this, Daniel. I think this is a very common question. And I think we're lucky to be in California, because in California today, we already have 55% of our power, which is zero carbon on average across the entire state. It's about 35% renewable, about 10% hydro, and 10% nuclear. So we already about more than halfway there, and we have very ambitious policies: 60% renewable by 2030, 100% by 2045. But even where we are today, and that's part of the graph I showed with my heat pump and the bar chart here, it takes less gas to generate power in a power plant to power a heat pump than to burn gas in a water heater. So if you just want to reduce the use of gas today, and particularly if you want to close Aliso Canyon in SoCal, it's actually better to electrify everything, because it's going to take less gas to power the power plants that are still needed to power the grid than to use for all the water heaters and furnaces that are being used in LA. So the pathway to closing Aliso Canyon and reducing our gas dependency right now is electrification. And I don't think there's enough awareness of that among our policymakers yet. And it's part of our job to make sure that this there's understanding about this fact.
Let me throw in one thought here too. One of the nice things we have in Southern California is municipal utilities. And Daniel, I'd strongly encourage you to check out anytime you see David Jaco or Nancy Sutley from LADWP on a board or something, hear what they have to say. Because what they're planning is to increase grid capacity by 2.5 times what it was last year. That's to electrify all the buildings and all the cars. They haven't quite figured out trains and planes yet. But 20 years ago, the utilities were all like, electrify everything? Hell no. Then the engineers figured it out. And now they're like, oh yeah, we can do this. It's going to take 30 years.
Yeah, and the other thing I want to add to this, sorry, this great comment, is that California's grid is built for summer peak, air conditioning in the summer. And we're talking about largely adding winter load. And that winter load is going to fit in right there with our existing infrastructure from a transmission distribution point of view. We've got all the capacity we need to electrify all our buildings. It's already out there in terms of transmission distribution, in terms of, and there may be other reasons why we need to upgrade that. But by and large, we already have a lot of spare capacity in the winter that we're not using in the winter. So we're going to be better utilize this infrastructure, and therefore we're going to spread the cost over more sales, and that's going to be a lower cost and more efficiently used grid.
I have to be mindful of everybody's time. I have one last comment here, but before I get to it, I just want to say that there's a lot of amazing stuff happening in the chat window. If people aren't reading that, you should switch over to that and read all the links and the information going through there. Basically, the strategy here should be, I'm copying this chat to my clipboard and saving it to a Google Doc where I'll share it with the panelists. And I feel like what we'll have to do is summarize any questions we didn't get to, and we can send out an email after the fact. I think there's also questions if we could send out the presentation. So Will Wright can follow up with an email probably later in the week, just because there's so much information to process. But one thing that Luke Lombardi asked about was, Luke, if you're still on the line, bringing up the question, and this is always something I think we should think about, is embodied carbon. And when we talk about decarbonization, what kind of carbon are we talking about? And Luke, do you want to maybe frame your question? I want to make this our final question, and then we'll go on, and then we'll end the chat. Are you still online?
Yep. Can you hear me? Thanks, Jed.
Yeah, good.
Yeah, so we talked a lot about electrification and operational or carbon related to operations, but something we didn't really touch on was embodied carbon and kind of the impact of our materials. So I wanted to see if the panelists had any thoughts on if there are any policy changes either ongoing or in the pipeline for California regarding embodied carbon.
Yeah, I'll jump in briefly. I will say that my expertise is definitely around local governments, and the city of Berkeley has passed a low carbon concrete ordinance. So that's starting to get at least the concrete portion of the material impact for embodied carbon. But you're right, most of this is about operational electricity and natural gas. And Any other panelists have anything they want to add here?
The County of Marin also has a low carbon concrete code.
The only thing I would add is there's definitely a big issue, and is, we don't have the same level of policy tools to get at it from a code perspective yet, although we're beginning to. So we say it's the next frontier, and there's a lot of interest in addressing it. So more work to do.
Oh, one more thing. There is in July of 2021, there is mass timber will be allowed up to 18 stories. So that code change is in the works and almost complete.
Okay, Will, do you want to close with final comments there and close the meeting, Will?
Sure. Thank you everyone for joining us. I put my contact information there, will@aialosangeles.org. Please follow up directly. I'd love to have you get more involved personally with the AIA Los Angeles advocacy efforts. I've also put a link for our call for issue briefs. We put together an advocacy platform every year. But with that in mind, I want to say thank you to Amy and Jed and Pierre and Matt and Scott. I look forward to connecting with you all. And I know that AIA California will have a presentation on a very similar subject with Wade Killefer, who is the president-elect for AIA Los Angeles. And if I had access to that link, I'd send it right now, but I'll just tell everyone to Google it, and we'll make sure that you get connected to that program as well. So thank you so much.